All right, class. So last week we were learning what's a line, what's a segment, what's an angle, what's a ray. So today we're going to be talking about angles and segments. Right, a segment it looks like a line. It just part of it. It has a beginning and an end. Remember, line continues going on forever, both directions. But we're also going to be talking about angles. So here, questions 1 and 2. It says complete each congruent statement by naming the corresponding angle or side. We're going to start talking about congruency, right? I mentioned last week congruent. As a matter of fact, you guys can see the symbol on the inside. It looks like an equal sign. So the equal sign means same size. The wiggly thing on top means same shape. So there are two triangles in this case. They have the same shape and same size. So once again, that's what we call congruent. What I want us to do is learn how to read this statement. Now, segments, right? A triangle, when we think of a triangle, it has three sides, and those are segments. Let's say this triangle here, this triangle A, B, C. Each side, each segment, each side, I'm gonna label it by using the two letters. Order doesn't matter. So for one side, I can call this side AB, and I'm gonna draw a segment on top. I could also call it segment BA, right? AB, BA, the order of the letters does not matter. Another side, I'm going to call this AC or CA. And then the third side, I'm going to call this BC or CB. Once again, the order of the letters does not matter. This is how we're going to label sides. Now, when it comes to angles, there's two ways how we're going to label angles. One of them is just by using one letter. So I could call this angle A. Here at the bottom left, I could call this angle B. And here I could call this angle C. Notice for angle, I use it looks like an arrow, but it's a representation of an angle. So angles, we can use two letters, or we can use three letters. The way I'm going to label an angle using three letters, I'm going to use the three letters that are used in the triangle. But for angle A, I'm going to make sure that I keep letter A in the center. Okay, so what do I mean with that? I can call this angle CAB. I can also call this angle BAC. So when it comes to angles, we can use one letter only or three letters, right? Either way is correct. Sides, always two letters, right? Segments, always two letters. But for angles, it's either one letter or three letters. Let's take a look at the bottom right. There's angle C, right? If I wanted to use three letters, I will call this angle ACB, or I could call this angle BCA, right? The order of the letters is not that important as long as the corner C is left in the center when I use three letters. And as you guys can imagine, for angle B, I can call this angle ABC, or I could call this angle CBA, right? As long as I have B in the center, we're good. All right, so let's see. Here, question number 1, I'm giving you guys something here. I have triangle SRQ is congruent to triangle TUQ, and I want you to complete the statement, angle R. Now, notice how R, the letter R, is in the center. It's in the center of my triangle, on my first triangle. So on the other side, I'm going to use the letter in the center. So I'm comparing angles. I'm going to say angle R is congruent to, I can call this either angle U, if I want to use just one letter, or I could call this angle TUQ, or angle QUT. I can use one letter or three letters. Okay, now some of you might be wondering, how am I going to be able to type this? Now, in order for us to practice, sometimes I want you to do one angle, it's congruent to, and then I want you to complete it with three letters. Okay, so in order for us to be able to practice and for you guys to see how I want to have you answer it, I'm going to give it to you as a multiple choice. Okay, when I'm writing angles, I can either use one letter or three letters. When it comes to sides, no choice, two letters. Now let's take a look at question number 2. Notice I'm talking about a side, the side EF. The side EF, when I look at my first triangle, is the first two letters. So when I compare it here on the other triangle, I'm going to use the first two letters as well. So order matters. If I'm choosing the first two letters on the left, you got to choose the first two letters on the right. When it comes to sides, I'm going to use two letters that I could call this segment FE, or I could call this segment EF. When it comes to segments, I'm going to use those two letters. The order does not matter. So big emphasis here. When we talk about angles, we use one or three letters. We got a choice. When it comes to a side, two letters. Again, to make it easy to answer, I'm going to put a multiple choice, but make sure you guys keep that in mind. Angles can be one letter or three letters. Sides, only two. All right, now looking at questions 3 and 4, there's one rule that we call segment addition postulate, right? It kind of sounds fancy. Let me talk about that rule first. Now, segment addition postulate says if I have two segments, or three or more, if I have multiple segments, I can combine them, so I can put them together, and it makes a bigger segment. Right? If you guys break down the word segment addition postulate, segment, it's a segment, right? We know it looks like a line. It has a beginning and an end. Addition, well, it sounds like I'm adding. And postulate is the fancy word for rule. So segment addition postulate. Now, taking a look at our work here. So let's see question number 3. Now here it says find DC. Notice how there's no segment on top, right? I'm not asking find the segment DC, right? There's not a little segment thing on top. When we use two letters, DC, in reality, what I'm asking is find the distance, right? I'm not saying it's a line, array, a segment. When we use two letters, I'm asking find the distance. I want you to find the distance between point D and C, which is this distance, which I have it as 2 plus x. It would be nice if I knew the value of x, because then I can just substitute the value, right? 2 plus that value, and then that's it. So let me find out what the value of x is, and then I'll be able to plug it in there. So the way we're going to do this, let's take a look. What I'm going to do, I'm going to choose the whole segment. I'm going to try to find the whole segment, which is the segment EB. I'm trying to find a segment from the segments that I have at the bottom. I'm going to have one that starts on the left and goes as far as possible. In this case, let me say it. I'm going to use this segment, right? It starts on the left, on the farthest left, and it goes as far as possible. And then I'm going to use a segment on that starts on the right, so in this case B, and goes far left as possible. There is a space where they overlap. So for right now, let me just say 20. All right, that was the first segment. I'm going to add this with x plus 9. That gives me the whole segment. However, I'm going to subtract the part that they overlap because I only want to use it once. So I'm going to subtract it. So I'm going to say subtract. I'm going to put inside parentheses 2 plus x. Right. This segment, if you compare on the top, is 2 plus x. Because I'm using it twice, I'm going to subtract it once. And I know this is the whole segment. But interesting is that the whole segment, I see here, the whole segment is 2x plus 13. So I added, notice I use highlighters. I added the two segments that I highlighted in yellow. I subtracted the part where they overlap, and it is equal to the whole segment. Now that's the geometry part, the setup. The rest is just algebra. So let's take a look. Let me solve for x. I remember that I have to separate my sides through the equal sign. Let me get rid of parentheses if there's any. So on the left side, let me just write 20 plus x plus 9. When I distribute the negative sign, I'm going to have minus 2 minus x equals 2x plus 13. Right, I just got rid of parentheses. The next step I got to do is combine like terms. So I notice on the left side, there's 1x minus 1x. So that's 0x. Basically, they cancel out. There's no x's on the left side. When it comes to just numbers without an x, I see 20 plus 9 minus 2. So I'm just going to call that 27. Right, I said 20 plus 9 minus 2. So I said I call that 27. Now, on the right side, I just have 2x plus 13. All right, we mentioned that we're solving for x here. So I want the x by itself. So the plus 13, let me move it to the left side as a minus 13. Remember, we talked last week that I can move it to the other side and I switch the sign. Remember, opposite operations. So I have that 14 is equal to 2x, right? 27 minus 13 gave me 14. To get the x by itself, let me divide both sides by 2. So I think we can agree x is equal to 7. Now, one thing, let me go back to the directions. I'm asking, what's the segment 2 plus x? So x equals 7 is not my final answer, right? This is part of my work. I know what the value of x is. I'm going to use it here. 2 plus x, I know x is 7. So 2 plus 7, my segment should be 9. So once you solve for x, don't think that's it. Go back and find out the segment you're looking for. I'm going to solve for x in order for me to answer my question here. Find the segment DC is 9. All right, let's take a look at question number 4. I'm going to find a segment that starts on the far left and it goes and it stops somewhere. Probably doesn't make it all the way through. So I'm looking at this segment, which is 10. Then I'm going to look at a segment that starts on the far right and it doesn't quite finish. I know if I add those two segments, let's just say x plus 19. Oh no, this is not x plus, this is 10. Okay. So 10 plus 17 plus x. I added those two segments, but I notice there's a section where they overlap, which is this much. Interesting that I know that's x plus 16. So I'm going to say, let me subtract x plus 16. Notice I put the x plus 16 inside parentheses. And this is equal to, now the whole segment I can tell is x plus 19. Okay, now let me solve for x. What I'm going to do, let me get rid of parentheses first. So I have 10 plus 17 plus x. Let me distribute the minus. So minus x minus 16 is equal to x plus 19. I'm going to separate my sides through the equal sign. On the left side, when I combine like terms, x minus x, again, they cancel out because it's 0x. When I look at numbers, 10 plus 17 minus 16, I know that's 11. On the right side, I have x plus 19. If I happen to have x's on both sides, obviously move one of them. In this case, we don't. Now I'm trying to have the x by itself. So the plus 19, let me move it over as a minus 19. I know 11 minus 19 is a negative 8. So I have negative 8 is equal to x. I know the value of x now. I can complete my statement. Remember, here I'm asking, find MJ. So I want to know what's the distance between M and J. That's the whole segment. So I'm going to use this information that I have for X. I'm going to use it here. Notice how the whole segment is X plus 19. X equals -8. So in my mind, I'm really looking at -8 plus 19. So I'm just going to call that 11. My answer is 11. Right, I'm asking for MJ. I'm asking for the whole segment. All right, let's take a look at question number 5. There's two small segments. I can see X plus 29, and I can see 19. Those are two small segments. They do overlap. So let me just say X plus 19, X plus 29 plus 19. I added the two segments minus, I'm going to subtract the overlapping. I notice they overlap this much, which is LK. So I'm going to say minus, inside parentheses, let me have 2x plus 32. This is equal to the whole segment. The whole segment, I can tell it's 40 plus x. Again, this is the geometry part. I'm just setting it up. The rest is algebra. So let's take a look at this as an algebra question. Let's solve for x. Let me get rid of parentheses. So I have x plus 29 plus 19. When I distribute the minus, I get minus 2x minus 32. And this is all equal to 40 plus x. Separated the sides to the equal sign. When it comes to x's on the left side, 1x minus 2x, that gives me a negative 1x. Doesn't quite cancel out. Now, looking at the numbers, 29 plus 19 minus 32, that is a positive 16. And this is equal to 40 plus x. I have x's on both sides. There's a negative x on the left and there's a positive x on the right. I want to have them together, okay? So what I'm going to do, I'm going to move the x's to one side and anything that doesn't have a letter to the other side. So this minus x, I'm going to move it to this other side as a plus x. Notice I switched the sign. The positive 40, I'm going to move it to this other side as a minus 40. All right, so I know on the left side, 60 minus 40 is a negative 24. On the right side, 1x plus 1x, that's 2x. Right, we're not going to call it x squared, right? That's multiplication. Addition, we just say 2x. Now to get x by itself, let's divide this by 2. So that gives me that negative 12 is equal to 1x. Cool, now I know the value of x, and it's fine for x to be negative. I'm asking, what's mk? All right, gotta understand what am I asking here? The distance between m and k. Now mk is this one, x plus 29. I know the value of x. Remember, I just found the value of x, so I'm gonna plug it in here. X plus 29, so I have negative 12 plus 29, and that is 17. Notice how I added two small segments to make a bigger segment. Now, if they overlap, you gotta subtract the overlap. All right, let's take a look at question number 6. Interesting part is that here I don't see many segments at the bottom like I did on questions 3, 4, and 5. But the interesting part is that I see there's a small segment, there's another small segment, and there's another small segment. If I combine them all, so if I add them, it makes the whole segment. So the way I'm gonna set this thing up, I'm gonna go 5 plus 20 plus x plus x plus 18. Notice I added the 3 small segments, and this is equal to x plus 35, which is the big segment. Let me separate them to the equal sign. So on the left side, let me combine like terms. 1x plus 1x, that's 2x. 5 plus 20 plus 18, that's 43. And this is equal to x plus 35. When I have x's on both sides, I move one of them because I want to have them together. I want to combine like terms. So I'm going to move the x from the right side, right? This positive x, I'm going to move it to the left as a minus x. And this positive 43, let me move it to this other side as a minus 43. Remember, when the numbers cross the equal sign, so when they go from one side to the other, gotta switch the sign. On the left side, 2x minus 1x is just 1x. 35 minus 43 is just a negative 8. So x equals negative 8. I'm going to use this, but I go back to the question here. I'm asking find KL, the distance between K and L. Let me highlight this distance, which I see it as x plus 18. I know what x is, right? Negative 8. So I'm really looking at negative 8 plus 18, which is better known as 10. So you got to find the value of x and then use it. I'm asking for a measurement of a side. So I'm actually expecting a number. So solve for x and then plug it in where you need to plug it in. If you have any questions, you know where to find me.